Hi, welcome back to hostboxcse channel and back to computer architecture and organization series. Today we are going to see the topic called interface circuits in COA. The previous session I explained about the example for processor as well as followed by buses in COA. That means synchronous and asynchronous with the timing diagram, how the operation happening in the synchronous or asynchronous mode, where with the help of some real-time example for understanding purpose, timing diagram, and also multiple data transfer and read operation, at last data handshake protocol with real-time examples also. Today we are going to see the interface circuits in COA. You know, access and I/O devices, these are the part of the area. So here you have to now idea about the interface circuit, you know already. So interface circuit, and also you have to see the types of interface circuit like input interface circuit, output interface circuit, at last parallel port, the types of interface circuit you have, and serial port elaborately and with some real-time examples. So you know this is one of the important area in CS, stream of computer science engineering, and also COA. You may expect at least 5 more questions from this area, and this also slightly touching the digital electronics. Let's go for a session today. So interface circuit. Here generally what are the interface circuits? These are the circuit consist of the circuitry required to connect an I/O device to a computer bus, and also the side of the interface which connect to the computer has bus signals for address data control also. Then the side of the interface which connect to the I/O device has data path and associated controls to transfer data between the interface and the I/O device. This side is called as port. You can say another way, PORT, port. And also here the port interface circuit where you need port, it have two types, that is called parallel port and serial port. So now you have one more. So I will give one more point for understanding this port. We can say simply what means point. Port means it's a point which external device attached to the computer system. A point at which external device attaches to the computer system. This is for what? Send or receive the data. So you know in the day-to-day real life, you know, whenever you want to connect any device in the computers, you need some hardware and there will be a interface device will be there. You know, there is slot, you can say in another way, SOLT slot. For example, in your laptop or computer, you want to connect pen drive, there will be some port will be there. In the port you can connect or else if you want to connect some modem or something, you need some port where you can connect. That is the interface. That means for to create the communication between the two devices. You can say simply, right? Go for here parallel. Remember what is the difference between parallel port and serial port? Means in parallel port it transfer the data in the form of a number of bits, normally 8 or 16 are from the device. That means simultaneously it transfer the data like that. Then in serial port, transfer and receive the data only one bit at a time. Remember, so parallel bit, multiple bits are transferred simultaneously. In serial bit, only one. For serial port, you can say example the cable called RS232. Parallel port, you can say the example of printer. Then the processor communicates with the bus in the same way, whether it is a parallel port or a serial port here. And conversion from the parallel to serial and vice versa takes place inside the interface circuit only. So this entire thing, how the I/O interfaces communicate with parallel port and followed by how the interface devices connect with the serial port in the both sides. There will be one side and other side will be there when you go for interface circuits. So before going here, we have one diagram. So this is a general diagram where you have for data in, data output, something is that for understanding purpose where read operation, write operation, and here one more read data master. This is circuit for an status block in the for the above input interface circuits. Let's come back PPT, right? So here there will be two ways is the input interface. Here this is, see that look the diagram. This is a diagram for keyboard to processor connection where in bracket you can write input interface here. So here what are the commands here? Processor where keyboard data, keyboard status, that is a status register, a status block and data valid encoder circuit, and you have a encoder circuit and here keyboard switches there. So here how do you understand means Let's assume that, see this real time example for understanding purpose, don't write for the examination please. Sorry. So how it will communicate and how the data will pass and how what kind of output here it means. Here keyboard switches will be there. Let's assume that I am going to type a word, a character A or X in the computer. So this is full and full input. What happen means it will the data will move to the encoder circuit, and also the data will be converted to the ASCII format, and again the data will move to the keyboard data, this input interface base. And here what will happen means, here the status flag is there, it will decide the status will decide whether send the data or not. If send the data, it move to the processor and communicate. Whenever the processor respond, what happen, it will send the form of address and communication happen again with the keyboard data. And here r/w is there. What is mean the w is this means read or write data. Here the meaning is whether you want to read the data or write the data. For example, typing the system A, what will happen, it will display in the monitor immediately, like that. So or else if you want to write again, what happen, you can type abc a.txt and so on. So read or write, or else you already a.txt file is there, you want to view the information, that is hello hostboxcse, like that. You can go and view the content of the file like that. Either read or write the new, create a new file and write something. Here one more one more option is the signals followed here, master ID and slave ID. The previous session also explained something about this one. Here master ID means what, whenever the processor communicate with input interface master ID, that means what, ready to communicate, then the slave ready also will ready to give the information, and slave ready give the signal to the processor, and again communication start and go. So here don't bother with the output, we are just typing something and going to view in the computer, and whatever the typing in the computer, it move to the, it convert to the ASCII format, again the data will move, at last move to the processor here, again it will communicate and check whether read operation or write operation, address, memory location and so on, master ID or slave ready, and moreover if the data is valid, moreover it will check whether the data is valid or not. So if valid, based on the status flag conditions, and very important here, if at all valid, again it will communicate with the processor, continuous process, otherwise not. So these are the points about the keyboard to processor connection, input side, that is the one view. Another view, output interface. Now the display to processor connection, this means the connection between the processor and display, the monitor, like that. Let's assume that you have printer here. For better understanding, you have printer, display monitor with connected with especially printer, like that. Here output interface, here just assume that we have a process, in the process we have some data, the data will move to the register called display data, then display status register. So based on the status register, the signal will be about 1 means it will active and pass the data to the monitor here, otherwise not, same condition. And also we want to read the data or not, write the, but here also it follow by master ID and slave ID here. Remember, so easy and simple here. And moreover here one more stage called ideally is there. Here a new data I am showing, but ideally is, ideally means what, from ready signal, and ideally means what, the, if suppose the printer is already busy, it will send the ideal signal to the processor, again process send the data and wait for some time and communicate again with the printer. Let's assume the practical example, don't write for exam. For example, in the printer, you are already printing some 10 pages like that, 5th page going on. Now again, from the processor, your CPU, you are going to give the instruction, a file called a.txt, I want to print again. So if you try to print the again, we check it whether the new data or not, it keep in the buffer or somewhere, what on the status flag register, and come to here and be ready and communicate, and if already system printing something means what happen, it will say send the ideal signal to this processor and wait for some time. Once the all printers are completed, again the processor communicates with the output interface, at last it will give the instruction to the printer, at last we can receive the printout of the new file called a.txt and so on. So like that output interface also very important, communicate with the processor very easily, IO interface and IO accessing devices. Then here the keyboard is some points given here, the keyboard is connected to a processor using a parallel port here. Remember these are everything about the parallel processor, parallel port only. Here processor is 32 bits and uses memory mapped IO and the asynchronous bus protocol. On the process side of the interface, we have what, data lines, address lines, controller read or write line, master ready signal and slave ready signal. So I'm again repeating, for diagram definitely get minimum 2 marks for the university exams. Keep on concentrate the diagrams. And on the keyboards of the interface, what are the things about the keyboards of the interface? Here a encoder circuit which generates the code for the key pressed. So you are pressing here, you are going to type A or X. Here what happens, the encoder circuit which generates the code for the key pressed, and also debouncing circuit which eliminates the effect of a key bounce. That means a single key stroke may appear as multiple events to a processor. And also here the data lines contain the code for the key. At last valid line changes from 0 to 1 when the key is pressed. This causes the code to be loaded in the data in and SIN to be set to 1. That is, remember, SIN, that is status flag register is equal to 1, and SI, another condition, SI signal is equal to 0 also. So remember here, there will be in the diagram small mistake, what debouncing circuit. So in the previous one you see the diagram, interface diagram. Here the encoder circuit as well as followed by the debouncing circuit also will be here. Possibly you can add debouncing circuit. Yes, then we see about the input interface circuit. Here the drivers are turned on when processor issues a ready signal and address select the data in. And also SIN signal is generated using a status flag register, and also SIN signal is connected to the line D0 of the processor bus using a 3-state driver. And also address decoder select the input interface based on bits A1 to A31. Let's go for the diagram. Sorry for the inconvenience. Yes, so here this is a diagram somewhat complicated. Try to draw as soon as possible. If the question asks more, here keyboard everything, sir. And here we have read data, master ready, and also same we are going to see, this is called representing the status flag registers. Status flag, a signal is SI1 is equal to 1 or 0. 0 means nothing, 1 means is ready to take the data, and also it connected with the flip-flop device and so on. Valid data, valid or not, be clear. If valid, clear, and get the next data SIN and connect with this gates and so on. So diagram, after that we can explain these points. Back to PPT now. Here simple and easy. And also here the bit A0, what is a bit A0? Because it always determines whether the status or data register is to be read when master ready is active, and also the processor activates the slave ready signal when either the read status or the read data is equal to 1, like that. Then let's go for another example, printer interface to processor. Here we have how the processor and the processor connect with the monitor, the printer with the help of output interface devices. Just now we seen this diagram, printer interface processor, or you can say output interface using the parallel port. Okay, so just now I explained to you, no problem. Go for next one. Here some points given. Sorry, by mistake I repeated these points here. So as I explained, no, same points given here. Then output interface circuits, how the output interface look like. So the question asked sometime the difference between the output interface and the input interface device, or we can say explain the output interface circuit, or the question asked explain the input interface circuit. So whenever asked what happened, you have to draw the diagram and explain the points. It's not much complicated. You may have studied already digital electronics. So here the diagram where you have data out, handset control, ideal and valid. Just now I told ideal means if the system somewhat busy, it will say keep the process in the waiting stage. After that it will give permission, and again the process will be take some time continued. Here you have input lines D0 to D7, data out, and also Q0 to Q7 is the printer data, and also slave ready, and S out will be the read, that is status out, and the read status, load status, and master ready. Then address decoder consists of A0 to A1 and A1 to A31 address lines, and also some data will be there. The status register will be there. Let's see some points here. So simple and easy. Here the data lines of the processor bus are connect to the data out register of the interface. The status block S out is connect to the data line D1 using the 3-state driver. Remember here which is S out, here this is S out. This is connected with the help of 3-state driver. Then the address decoder select the output interface using address lines A1 through A31. This is the address decoder. Then the address line A0 determines whether the data is to be loaded into the data out register or status block is to be read or not, like that. If the load data is remember, if the load data line is 1, then the value line is set to 1. If the idea line is 1, then the status block SOut is set to 1 here. So based on signal changes, the operation will held on the computer, whether you read or write operation. Then go for next one. One more diagram given. This is the combined IO interface combined IO interface circuit. So this is the one where you have data in, data out, and sec and control. This combined one. Just now you see two diagrams. No, combined one. Here the address bits A2 through A31, that is 30 bits, are used to select the overall interface. And also address bits A1 through A0, that is the 2 bits select one of the 3 registers, namely data in, data out, and status under the status register. Then the status register contains the flag SIN and SOut in bits 0 and 1. And also data lines PA0 through PA7 connect the input device to the data in register. See the diagram and write the connection. That's it. That's the operation and idea about this diagram. Then the data out register, what happened? It connects the data lines on the processor bus to lines P0 to PB7, which connect to the output device here. See here PP0 and P up to P7 data out register. At last, separate input output data lines for connection to an IO device. So these are the operation happening when you do something with the computer, behind the computers, backside of the computers. Then serial port. Now go to serial port. Serial port, remember what? We can transfer the data one by one only. At a time we can transfer only one data, it means one bit of data. Sorry, we can transfer data at a time, only one time. Here it is used to connect the processor to IO devices that require transmission of data one bit at a time only. Then it also communicates in a bit serial fashion on the device side and bit parallel fashion on the bus side also. Here the transformation between the parallel and serial format is achieved with shift registers that have the parallel access capability. Let's go for the diagram. Here this we are forget about the parallel port. We are going to concentrate on the serial put here. Just assume that we are connecting to some input device. It may be modem or anything, or key some other input device connected. First thing, whatever the data will be in the 8-bit form, 8-bit data. Remember, the data will be the 8 bits of data. Whatever the data was shifting, it moved to the shift register, input shift register, then the data moved to the data in. This is the register where it will transfer the data to the status flag here. Status flag is okay, means if it has status flag okay, it go and it will forward the data to the data out. So first we are sending the data, input data, it will be moved to the input register, and in the input register in the 8 bits of data. So data, what are the 8 bits of data, everything passed to this data out also. Again the data output, the data out transfer the 8 bits of data to the output shift register here. So after completing what happened, we can view the operation completed, we can get the result of the operation, what task we are going in the IO devices with the help of IO devices. This is a simple one, very easy. Here what are the 8 bit of operation held here. The remember here the signal is SIN, that is SIN is equal to 1 means what? Load the new data and the data move to the data in register. Remember, if SIN signal SIN capital letters, that is status flag in, is equal to 1 means what? Load the new data to the data in register. And if SIN is equal to 0 means what condition? That means the processor read the data. The processor read the data and decide whether you want to continue read operation or write operation. Moreover, apart from this, to the combination happening here, we need support of the status and control register, where it followed by the serial interface, receiving clock, transmission clock, and chip and register select. Here you have what? You have data lines of D0 to D7 and my address, RSI, RSO, and R/W ready accept. So if at all doing the proper operation where you want to read the data or write the data with the help of input devices, whether you want to read data or write the data, based on the chip register select, you can do anything here, ready accept. If at all data is ready, it will give ready signal, and accepted means what happen? If at all data accepted, suppose you want to read a file, the task is accepted by the computer and these interface devices, what happen? We have one more things called interrupt record, interrupt request. So interrupt request record the status and control. At last, the operation will complete. So if you want to read the data or write the data also, you to go and check the interrupt request. In the interrupt request, forward to the status and control signal where you have receiving clock and transmission clock. That means within a fraction of seconds we have to complete the task. So at last we can view the data in the serial input. So these are the points about the serial input. Let's see some points here. Here the input shift register accept input 1 bit at a time from the IO device, and also once all the 8 bits are received, the contents of the input register are loaded in parallel into the data in register. What I told just now. Then the output data in the data out register are loaded into the output shift register. Bits are shifted out the output shift register and sent out to the IO device 1 bit at a time. Remember, as soon as the data from the input register are loaded into data in, it can start accepting the another 8 bits of data. Continuous process. Then input register and data in registers are both used at input, so that the input register can start receiving another set of 8 bits from the input device after loading the contents of data in. Before the processor reads the contents of data in, this is like that. This is called a double buffering. So this another name is called double buffering. 2 mark you can expect. So remember, what are the advantages of serial port? One more means it's a general purpose one. General purpose means what? We can connect with any kind of input devices or anything. For example, you can say modem, or you can connect the printer. Whatever you can do with the serial port. The only thing is we can transfer the data group of at a time. Only one bit of data. Can transfer data very less. One bit of data can transfer like that. So example, you can say either RS through 232 cable, or you can say modem also. I hope that understand about this one. What are the parallel port and what are the serial port? How it will help to communicate between the IO interface circuit and so on. In the upcoming session, definitely we see the standard IO interface like PCB, SCSI and so on, bus also. And if you have any queries or any command, you can communicate with the social media or type in the YouTube channel command box and so on. Thanks for watching this video. Please like, share, comment, support and press bell icon for more updates. Thank you.